Okay, so we're going to look at another application now of the chain rule, which allows us to link rates of change for various interlinked variables. Now, a rate of change is usually measured with respect to time. So what we're talking about is having a d something dt, where it could be the rate of change of distance with respect to time, or velocity with respect to time if we think of mechanics, and velocity and acceleration, but other things as well. So as I've said here, the easiest way to demonstrate this is actually look at some examples. So Eg22, the radius of a circular ink blot is increasing at a rate of 0.3 centimeters per second. Find, in terms of centimeters squared per second, two significant figures, the rate at which the area of the ink blot is increasing at the instant when the radius of the blot is 0.8 centimeters. So the find bit is area, the rate of change of area. So what we're looking to find is dA dt. And using the chain rule, as we've been practicing over the recent weeks, we can use that information to split that up into dA d something multiplied by d something dt. As long as the variable, the d something, is the same, to all intents and purposes, they would cancel, and you'd have dA dt equals dA dt. So we've got a variable a and a variable t, and we want to introduce a third variable. So if we go back to the question and have a look at what other information we're given a rate of change for dr dt. So we also know dr dt is equal to 0.3. So in our case, the third variable is radius. The d something is dr. So chain rule, dA dt equals dA dr times dr dt. We know dr dt, we've given it, so we need to find dA dr. So we need a relationship between A and R. So we're told that the ink blot is a circle. So therefore we know that A equals pi r squared, which I can differentiate to get 2 pi r. So if we sub in 1, dA dt, the rate of change of area, is going to be dA dr, which is 2 pi r, multiplied by dr dt, which we know is 0.3. So let's go back to the question. Find in centimeters squared per second the rate at which the area of the ink blot is increasing at the instance when the radius is 0.8. So I know here that that's 0.6 pi r when the radius is 0.8. The rate of change of area with respect to time is going to be 0.6 times pi times 0.8, which is the radius. we want the answer to two significant figures. So 0.6 times pi times 0.8 equals that. So if we write that down, off the screen, 1.50796, etc., etc., which to two sig figs is going to be 1.5. 1.5 centimetres squared per second. So that's the approach that you need to do. You'll be given a question. Starting place would be, right, what am I trying to find? In this case, it's the rate of change of area. So I need the dA dt. Then deconstruct that with your d somethings into the chain rule, and then go hunting what that extra variable is going to be.